Hello, I welcome you all to this channel again. So this will be the last part of KSET 21 paper discussion. So in this, I'll be taking organic part, question number 50 to 64. So along with that, I will be taking one or two questions which can be challenged. So in this part itself, 50 to 64 itself, which I have not covered so far. So in the last video, I had uploaded the questions which can be challenged. So there one or two questions I have missed. So that comes under 50 to 64th question. So that part also I'll be taking it in this itself. So please do watch the video till end. So let's begin with the questions. First, we shall start with the 50th question. This is in fact easy question. The following conversation it is achieved by aldehyde, benzaldehyde, it has been converted to cyanobenzene. So if we know that these three reactions, Hoffman reaction, very basic reaction, similarly Steinmetz reaction and on Richter rearrangement, these three, if we know that, we can easily say that these three iವು ಮೂರರಲ್ಲಿ ಇದು ಯಾವುದು aldehyde ಇಂದ cyanobenzene ಗೆ ಕನ್ವರ್ಷನ್ ಆಗೋದಿಲ್ಲ ಅಂತ ಗೊತ್ತಾದರೆ easily we can go with option D as the answer. But we shall see why these three Hoffman's reaction, Steinmetz reaction and on Richter rearrangement the answer alla yake ant nodidre. So first, if you consider Hoffman reaction it is for the conversion of amide to amine in presence of strong bases and halogens, or say like Cl2 in such in the presence of such reagents we can bring about this reaction. So illi namge amines product alla in this particular reaction ಕೊಟ್ಟಿರುವಂತದ್ದು ಅಮೈಡು ಅಲ್ಲ reactant, so therefore it cannot be this Hoffman reaction. So Steinmetz reaction, as you all might be knowing, so it is for the conversion of say diazonium salt to suitable halo benzene ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು ಅಥವಾ ಸೊ ಫಾರ್ ಸೈನೋಬೆನ್ಸಿನ್ ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ಈ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ನೋಡಿದ್ರೆ ಸೈನೋಬೆನ್ಸಿನ್ ಮಾಡಲಿಕ್ಕೆ ಇಲ್ಲಿ ಕಾಪರ್ ಸೈನೈಡ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಇಟ್ ಇಸ್ ಪಾಸಿಬಲ್ ಫಾರ್ ಡಯಾಸೋನಿಯಂ ಸಾಲ್ಟ್ ವಿ ಕ್ಯಾನ್ ಗೆಟ್ ದ ಸೈನೋಬೆನ್ಸಿನ್. ಕೋರ್ಸ್ ಪ್ರಾಡಕ್ಟ್ ಬರುವಂತ ಚಾನ್ಸಸ್ ಇದೆ, ಬಟ್ ದ ಸ್ಟಾರ್ಟಿಂಗ್ ಮಟೀರಿಯಲ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಅನಿಲೀನ್ ಹಿಯರ್. ದ ಗಿವನ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಮಟೀರಿಯಲ್ ಇಟ್ ಇಸ್ ಆಲ್ಡಿಹೈಡ್ ಅಂಡ್ ಆಲ್ಡಿಹೈಡ್ ಅನ್ನ ಅಮೈನ್ ಮಾಡಿ ಕನ್ವರ್ಷನ್ ಮಾಡಿಕೊಂಡು ದೆನ್ ಕನ್ವರ್ಟಿಂಗ್ ಇಟ್ ಟು ಸೈನೋಬೆನ್ಸಿನ್ ಆ ತರದ್ ಯಾವುದು ರಿಯೇಜೆಂಟ್ಸ್ ಕೊಟ್ಟಿಲ್ಲ. ಸೊ ದೇರ್ಫೋರ್ ದಿಸ್ Steinmetz reaction it is also not suitable in this case. So third one, von Richter rearrangement. So this also, like cyanide, it is one of the reactant, but the product of this reaction, this named reaction, if you know, so it will be for bromo and nitro substitution iruvanta benzene, it can be converted to carboxylic acid. The product, though we are using cyano reagent, cyanide and reagent age use ಮಾಡ್ತಾ ಇದ್ರು, the product it will not be cyanide or cyano product ಇರೋದಿಲ್ಲ, it will be acid. So therefore even it cannot be von Richter rearrangement. And the last one we are left with Bachmann rearrangement. Of course ಇಲ್ಲಿ ನಮಗೆ reagent ಇನ್ನೊಂದು ಯಾವ್ದು ಬೇಕು ಅದನ್ನು ಕೊಟ್ಟಿದ್ದಿದ್ರೆ that would have been suitable. So actually here it is hydroxyl amine ಬೇಕಾಗ್ತದೆ in the first step, and then in the presence of acid that product whatever we get, benzaldehyde hydroxyl amine ಜೊತೆ react ಆದಾಗ what we get is this imine product we get, and this one in acidic environment it is possible that it can undergo rearrangement. So rearrangement ಹೇಗಾಗುತ್ತೆ it has been shown here. So like OH it will be taking up one proton and H2O ಆಗ್ತದೆ, and therefore this hydrogen it can migrate, or this hydrogen electrons it can migrate here, and this water molecule it can be removed and cyanobenzene product ಬರ್ತದೆ. So most appropriate answer NH2OH ಅಂತ ಕೊಟ್ಟಿದ್ರೆ reagent it would have been good, but still we can say that option D itself is the correct answer for this question. So the next question, 51st question, it was little tricky, but if you know some basic concepts it wasn't difficult. So what they say is that the reaction of R, stereochemistry or configuration they have given 2-bromobutane, R2-bromobutane, if it is reacted with acetate ion in presence of non-polar solvent. ಇಲ್ಲಿ ಇದು ನಾನ್ ಪೋಲಾರ್ ಸಾಲ್ವೆಂಟ್ ಅನ್ನುವಂಥದ್ದಕ್ಕೆ ಬಹಳ ಇಂಪಾರ್ಟೆನ್ಸ್ ಇದೆ, because it indicates that in non-polar solvent SN2 mechanism it should happen. So polar solvent idre that will favor the SN1 mechanism, but because it is non-polar solvent we should consider the reaction mechanism as SN2. SN2 ಆಯ್ತು on 2-bromobutane ಅಂದ್ರೆ product ಏನು ಬರ್ತದೆ that is to be identified. So stereochemistry good knowledge if you have, you can solve this. So this is the reactant that they have mentioned. So R configuration ಅಲ್ಲಿ ಬರೋ ಹಾಗೇನೆ ಬರ್ದಿದ್ದಾನೆ. Priority wise assign ಮಾಡಿದ್ರೆ of course hydrogen least priority, have kept it away. And these three groups if I consider, bromine it is first priority, ethyl second priority, third priority it is for methyl group, and they are tracing clockwise path, so therefore no doubt this is R. right? So now this, if undergoes reaction, nucleophilic substitution reaction via SN2 mechanism, right? Let's assume that this bromine, it is towards the observer. So therefore in SN2 mechanism, the incoming nucleophile, it has to approach from rare side. ಎಕ್ಸಾಕ್ಟ್ಲಿ ಈ ಬ್ರೋಮಿನ್ ಏನಿದೆ ಅದಕ್ಕೆ ಹಿಂದಿನ ಸೈಡ್ ಇಂದ ಅಪ್ರೋಚ್ ಆಗುತ್ತೆ. ಸೊ ಹಿಂದಿನ ಸೈಡ್ ಇಂದ ಅಪ್ರೋಚ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಪ್ರಾಡಕ್ಟ್ ದಲ್ಲಿ ವಿ ಕ್ಯಾನ್ ಸೇ ದಟ್ ದ ರೇರ್ ಸೈಡ್ ಇಟ್ ವಿಲ್ ಬಿ ಆಕ್ಯುಪೈಡ್ ಬೈ ದ ಇನ್ಕಮಿಂಗ್ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್. therefore acetate ion have shown it here. Fine. And this one bromide ion, it will be the living group, it leaves away. And simultaneously ಇನ್ನೊಂದು ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಉಳಿದಿದ್ದ ಮೂರು ಗ್ರೂಪ್ಸ್ ಏನಿದೆ, ಇನ್ಕಮಿಂಗ್ ಗ್ರೂಪ್ ಆಯ್ತು, ಹೋಗೋದು ಗ್ರೂಪ್ ಆಯ್ತು, ಈ ಮೂರು ಗ್ರೂಪ್ಸ್ ಏನಿದೆ ಸೊ ದೇ ವಿಲ್ ಅಂಡರ್ಗೋ ಇನ್ವರ್ಷನ್. So how they undergo inversion, that I have shown here. Let's assume that bromine, it is towards the observer, and these three groups, other three groups, they are away. And whenever this OAC, it is approaching the carbon, bromide, it leaves away. Simultaneously in SN2, it is expected that these three groups, which are say facing away from the observer now, with the approach of the incoming nucleophile, simultaneously they will be towards the observer, and the product, it will be this. So therefore it is expected that these three groups, they will not retain the original orientation. So avugaladdu configuration invert ಆಗಬೇಕು, right? So if we know that, and correctly if you write the incoming nucleophile and the other groups, if you decide the configuration at this chiral center now, again, so hydrogen in this case, it is towards the observer. Other three groups, acetate, it has to take first priority, ethyl second priority, methyl, it is third priority. So now again, if you see, it is tracing R, or if it is tracing this clockwise direction, it should be called as R. But we know that the hydrogen least priority group, it is not away from the observer, it is towards observer. So in that case, the configuration whatever we have seen now, so that should be reversed. So therefore this will be S. So the product of this reaction, without any doubt, it should be S2-butyl acetate, that is option B, right? So ಇಲ್ಲಿ ನಿಮಗೆ ಆಪ್ಷನ್ಸ್ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ that the product, it should be either R or S. But if you know that during SN2 inversion of configuration ಆಗತ್ತೆ ಅನ್ನೋದು ಗೊತ್ತಿದ್ರೆ easily you can answer this. But definitely the question, it is not that straight away. ಯಾಕಂತ ಹೇಳಿದ್ರೆ ಯೂಶುವಲಿ ನಾವು ಆ ಥರ ಅನ್ಕೊಂಡಿರ್ತೇವೆ, ಯಾವಾಗಲೂ SN2 ಇಟ್ ರಿಸಲ್ಟ್ಸ್ ಇನ್ ಇನ್ವರ್ಷನ್ ಆಫ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅಂತ ಅನ್ಕೊಂಡಿರ್ತೇವೆ. ಬಟ್ ದ ಫ್ಯಾಕ್ಟ್ ಇಸ್ ದಟ್ ಇಟ್ ಮೇ ನಾಟ್ ಹ್ಯಾಪನ್ ಆಲ್ವೇಸ್, ರೈಟ್? ದಟ್ ಇವನ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ ಪ್ರಯಾರಿಟಿ ಆಫ್ ದ ಇನ್ಕಮಿಂಗ್ ಗ್ರೂಪ್ ಅಂಡ್ ಲಿವಿಂಗ್ ಗ್ರೂಪ್. ಸೊ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಬಟ್ ಇನ್ ದಿಸ್ ಕೇಸ್ ನೀವು ಅದನ್ನ ಸ್ಟ್ರೇಟ್ ಅವೇ ಕಾನ್ಫಿಗರೇಷನ್ ಇನ್ವರ್ಟ್ ಆಗುತ್ತೆ ಅಂತ ಡಿಸೈಡ್ ಮಾಡಿದ್ರು, ಯು ವಿಲ್ ಗೆಟ್ ದ ಕರೆಕ್ಟ್ ಆನ್ಸರ್, ದಟ್ ಇಸ್ ಆಪ್ಷನ್ ಬಿ, ವಿಚ್ ಇಸ್ ದ ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಫಾರ್ ದಿಸ್ ಕ್ವಶನ್. ದ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. This is also relatively easy itself if you know the formation of ozonide mechanism, right? So ozonide mechanism, you can see it here. As you can see the ozonide mechanism, say ozonide, it can act as 1,3 dipole. So 1,3 dipole ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ಬೇಕಂದ್ರೆ ಈ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನ ಇದರ ಕಡೆ ಡಿಲೋಕಲೈಸ್ ಮಾಡಿ ಈ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಅನ್ನು ಇದರ ಮೇಲೆ ಮೊದಲು ತೋರಿಸಬಹುದು, or even it can be shown in this manner. Say like electron movement simultaneously, if I show this double bond, it attacks this oxygen atom. So this pi bond, it will shift towards this, and simultaneously this or maybe I can start from here, that this minus charge, it attacks here, double bond, it migrates here, and this pi electron, it will shift towards this oxygen atom to produce molozonide. This is the first step, right? So this is simply 1,3 dipolar addition to alkene. So first step, it should be 1,3 dipolar addition. So the next step is that molozonide, so molozonide, it will undergo reverse of 1,3 dipolar addition, reverse reaction ಆಗುತ್ತೆ. And during that step you can expect the break of carbon carbon bond. ಈ carbon carbon bond break ಆಗಿ ಮತ್ತೆ ನಿಮಗೆ 1,3 dipole and other alkene or other double bond, it will be not alkene but double bond, it will be generated. So the second step, it should be reverse of 1,3 dipolar addition, right? So ಇಲ್ಲಿ first step ಅಲ್ಲಿ ಏನಾಗಿದೆ ಅದರದ್ದು reverse ಆಗುತ್ತೆ, you will get these two products. But further these two, they again react in 1,3 dipolar addition way itself. Now this can act as 1,3 dipole, and this can be the 1,3 dipolophile. So adanna adar jothe bind aguvanta species agi idu act agutte. But it is necessary that, so now if you consider this dipole, ಇಲ್ಲಿ minus charge ಇದೆ, ಈ pi electron ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ ಇದರ ಮೇಲೆ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. So carbonyl, if you consider like carbonyl carbon, it will be having positive charge, and oxygen, it can be having slightly negative charge. So therefore ಇಲ್ಲಿ ನಿಮಗೆ positive charge ಬರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ towards this carbon, this oxygen, it has to face. So therefore now we can say that it is flipping of this carbonyl ಅನ್ನ invert ಮಾಡಿಕೊಂಡು, then we can again consider the 1,3 dipolar addition. So the electron movement has been shown with the help of green arrows, and ultimately what you get is ozonide. So of course ozonoid mechanism ಗೊತ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ straight away this question it can be answered. So the option it should be consecutive 1,3 dipolar this one 2 1,3 dipolar cycloaddition followed by reverse. No, the correct answer it is here 1,3 dipolar cycloaddition, reverse of 1,3 dipolar cycloaddition followed by 1,3 dipolar cycloaddition again. So this is the correct answer for the question, option D, right? So first step dalli 1,3 dipolar addition ಆಗ್ತಾ ಇದೆ, second step dalli reverse of 1,3 dipolar addition, third step again it is 1,3 dipolar addition. That is exactly option D, which is the correct answer for this question. 53rd question, very simple. If you know even the basics of pericyclic, or say if you know the basics of cycloaddition reactions, easily this question it can be answered. The diene and dienophile for the preparation of the following component ಕೊಟ್ಟಿದ್ದಾರೆ. ಸಿ ಅವರೇ ಹೇಳ್ಬಿಟ್ಟಿದ್ದಾರೆ ಡೈನ್ ಇರಬೇಕು ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ಡೈನ್ ಇರಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ the reactant it should be diene. Cyclopentane it is not possible, ಯಾಕಂದ್ರೆ cyclopentane ಅಂದ್ರೆ it is not diene. So here also it is cyclopentene, this also not diene, right? So here it is cyclopentadiene, this can be the answer, or here the one more it is option D, which is also cyclopentadiene. I'm going to diene ಬೇಕಾಗಿರೋದ್ರಿಂದ either B should be answer or C should be answer, right? So ಏನು ಮಾಡದೇನು ಇದನ್ನ ವರ್ಕೌಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರ್ತದೆ. So the other thing that they say is just acetaldehyde ಅಂತ ಹೇಳ್ತಾರೆ. So acetaldehyde ಅಷ್ಟೇ ತಗೊಂಡ್ವಿ ಅಂತ ಹೇಳಿದ್ರೆ aldehydic functional group final reactant ಅಲ್ಲಿ ಉಳಿಲಿಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ. So therefore the other reactant dienophile it should be different than acetaldehyde. So therefore other basis ಮೇಲೂ you can readily conclude that option D is the correct answer for this, right? So but exactly mechanism, how to reactants they react to produce this product ನೋಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ cyclopentadiene this is one of the reactant, and acrylaldehyde that will be the other reactant. This double bond it will act as dienophile, this will be diene. So this pi bond it can be shifted between these two carbon atoms, this pi bond it can be shifted between these two, right? And simultaneously this pi bond it will be shifted here, right? And now this CHO group it will remain as it is, these two carbon atoms they are present here. So straight away option D it is the correct answer for this cyclopentadiene and acrylaldehyde, they are the correct reactants which can produce this product. 54th question. So this is one such question which is little doubtful, right? So why I am taking much time to make this video, it is mainly because of this question. So I was having a doubt over this, right? So I did lot of referencing. I seriously find that some error it is suspected in this question, but exactly ಅದನ್ನ ಚಾಲೆಂಜ್ ಮಾಡಲಿಕ್ಕೆ ಬೇಕಾದಂತ ಸ್ಟ್ರಾಂಗ್ ರೆಫರೆನ್ಸ್ ಸಿಕ್ಕಿಲ್ಲ. ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಡೂ ದಟ್. ಇಫ್ ಯು ಗೆಟ್ ದಟ್ ಡೆಫಿನೆಟ್ಲಿ ಐ ಹೋಪ್ ದಿಸ್ ಕ್ವಶನ್ ಕ್ಯಾನ್ ಆಲ್ಸೋ ಬಿ ಚಾಲೆಂಜ್ಡ್, ರೈಟ್? So from one standard say book chapter, it is published by Royal Society of Chemistry RSC. So from that book chapter, one particular chapter it is fundamentals of quenched phosphorescence O2 sensing, idu chapter inda nanu ee diagram annu ತಗೊಂಡಿದ್ದೀನಿ. So if you understand this diagram, or even if you know the basics of quenching, we can find that always these quenchers they will be acting as acceptors. Electron acceptors ಆಗಿ ಆಕ್ಟ್ ಆಗ್ತಿರ್ತದೆ. ಆ ಫ್ಲೂರೋಸೆನ್ಸ್ ಮಾಲಿಕ್ಯೂಲ್, ಫ್ಲೂರೋಸೆನ್ಸ್ ಕೊಡ್ತಿರುವಂತ ಮಾಲಿಕ್ಯೂಲ್, ಆರ್ ಸೇ ಫಾಸ್ಫರಸೆನ್ಸ್ ಕೊಡ್ತಿರುವಂತ ಮಾಲಿಕ್ಯೂಲ್ that will be acting as a donor, right? So but if you come here, ಅವ್ರೇನ್ ಹೇಳ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ the given answer for this now when I am recording this video, first tentative K answers have come, and option B they give us the correct answer, lower triplet energy than acceptor ಅಂತ ಹೇಳ್ತಾರೆ. Quencher it should have lower triplet energy than acceptor ಅಂತ ಹೇಳ್ತಾರೆ. So quencher itself is acceptor ಆಯ್ತು ಅಂತ ಹೇಳಿದ್ರೆ quencher having lower triplet energy than acceptor, it is little doubtful. Therefore I discussed this with the experts in the field who has done little research and a lot of experience in this field. ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡಿದಾಗ ಗೊತ್ತಾಗಿದ್ದು ಅಂತ ಹೇಳಿದ್ರೆ they are suspecting that ಇದು acceptor ಅಲ್ಲ donor ಆಗಬೇಕಾಗಿತ್ತು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ, right? So the other possibility also that I am thinking is that maybe ಇಲ್ಲಿ sentence frame ಮಾಡೋ ಕಡೆ ಏನಾದರೂ ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಮ್ ಆಗಿದೆ ಅಂತ ಅನ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ. So if you look at this diagram itself, what you find is that this one, if you consider that say acceptor level, inside this itself you consider that this is donor level, this is acceptor level, triplet level ಅನ್ನ acceptor level ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಅದಕ್ಕಿಂತನೂ ಈ ಫ್ಲೋರೋಸೆನ್ಸ್ ಮಾಲಿಕ್ಯೂಲಿನ acceptor level ಕಿಂತನೂ ಇದರದ ಎನರ್ಜಿ ಲೆವೆಲ್, ಕ್ವೆಂಚರ್ದ ಎನರ್ಜಿ ಲೆವೆಲ್ ಕಡಿಮೆ ಇರಬೇಕು ಅಂತ ಹೇಳಬೇಕಾಗಿತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇಟ್ ಶುಡ್ ಹ್ಯಾವ್ ಬೀನ್ ಲೈಕ್ ಲೋವರ್ ದ್ಯಾನ್ ಟ್ರಿಪ್ಲೆಟ್ ಎನರ್ಜಿ ಆಫ್ acceptor, ಆ ತರ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬರಬೇಕಾಗಿತ್ತು. ಸೊ ಐ ಸೀರಿಯಸ್ಲಿ ಸಸ್ಪೆಕ್ಟ್ ಸಮ್ ಎರರ್, ಬಟ್ ಎನಿ ಹೌ ಐ ಕ್ಯಾನ್ ಜಸ್ಟ್ ಸೇ ಯು ದಟ್ this is the given answer, right? So but maybe proper referencing, if you do, if you can get a very strong reference to question this particular question, definitely I suspect or I expect someone of you should do that, right? So little doubtful is that question. Fine. So the next question, this is very easy based on 313 NMR, and previously in CSIR net this kind of questions have come. Not exactly e question bandide anta ankolodilla, but similar question it has come in CSIR net. So very simple one, even if you know the basic range of C13 shifts, this question it can be answered. See, basic range in a rough way, if at all I have to give, sp3 carbons, they will give you C13 shift, NMR shift in 0 to 50 range, and sp3 carbons which are attached to electronegative atoms like oxygen, nitrogen and all, usually they will give little high chemical shift value, 50 to 100, right? sp2 and sp carbons, they will be 100 to 150 range it can vary a little, rough range ಇದು ಕೊಡ್ತಾ ಇರೋದು. And carbonyl, definitely it will be at higher end, say 160 plus ಇರುತ್ತೆ in most of the cases, right? So it will be the carbonyl carbon, it is the carbon which can give you highest chemical shift in C13 NMR. ಇಷ್ಟು ಬೇಸಿಕ್ ಐಡಿಯಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರು, some options they can be definitely eliminated in this case. See, first option readily it can be eliminated because a carbon atom, so a carbon atom, it is here, this is attached to oxygen, so ಇದು ನಿಮಗೆ 19 chemical shift value ಕೊಡುವಂತದ್ದು, 19 chemical shift value for A it is totally not expected, because even if you have very basic idea of NMR, this can be done, so therefore option 8 cannot be the answer, right? And the option remaining options, if you check, A at 52, A at 52, A at 52, just same. The other one that you can guess is E. This is simple sp3 carbon, so therefore below 50 it is expected, that is E. So if you refer to E, it is in this case anyhow this is wrong, E19, E19, E19. So in other three options based on A and E chemical shift values, you cannot do anything because they are just the same. So next, if you can or if you know that the carbonyl it has to give little, it has to give little high carbon 13 chemical shift, ಅದು ನಿಮಗೆ ಸ್ವಲ್ಪ ಜಾಸ್ತಿನೇ ಬರಬೇಕು ಅಂತ ನೋಡಿದ್ರೆ B it is expected 160 plus ಬರಬೇಕು. So in this case they say that B it is 143, right? It is not possible because this is typical sp2 range ಗೆ ಬಂದ್ಬಿಡ್ತದೆ, normal sp2 ಬಂದ್ಬಿಡ್ತದೆ. Carbonyl definitely it will be 160 plus, of course it will be 170, 180 ಹಾಗೆ ಬರ್ತಾ ಇರ್ತದೆ. ಇಲ್ಲಿ 167 ಬಂದಿರೋದಕ್ಕೂ there is good reason, we shall see that. So but based on this, what we can discard is that B 143, if you identify that this is wrong, based on that we can discard A as well as B. We are left with C and D. Here there are chances, if you do not know the proper concept, here there are chances that you can go wrong, right? So ಇವೆರಡರಲ್ಲಿ ಯಾವ್ದು ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಅಂತ ಐಡೆಂಟಿಫೈ ಮಾಡೋ ಕಡೆ ತಪ್ಪಾಗುವಂತ ಚಾನ್ಸಸ್ ಇದೆ. So like exactly now consider ಮಾಡಲಿಲ್ಲ situation, just if we think that electronegative atom it is more close to C than compared to D ಅಂತ ಆ ತರ ವಿಚಾರ ಮಾಡಿದ್ವಿ ಅಂತ ಹೇಳಿದ್ರೆ, so we expect that C it should have more chemical shift than D, right? So C ಜಾಸ್ತಿ ಇರಬೇಕು ಅಂತ ಹೇಳಿ ರಾಂಗ್ ಆನ್ಸರ್ ಮಾಡುವಂತ ಮಾರ್ಕ್ ಮಾಡುವಂತ ಚಾನ್ಸಸ್ ಇದೆ. ಬಟ್ ಇನ್ ದಿಸ್ ಕೇಸ್ this is alpha beta unsaturated carbonyl, so if you have alpha beta unsaturated carbonyl, you can expect this resonance it will be strong, this pi bond will be shifted here and oxygen it will take up minus charge. So if that happens, plus charge it will be over this D carbon atom, and because of this gets de-shielded. So idu de-shield ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಇದರದ್ದು chemical shift ಜಾಸ್ತಿ ಬರಬೇಕು, therefore this will give you higher chemical shift than compared to that of this. So ಈ ಎರಡು ಆಪ್ಷನ್ ಅಲ್ಲಿ ಇಲ್ಲಿ ಎರಡಷ್ಟೇ ಚೇಂಜ್ ಮಾಡಿದ್ದಾರೆ, that is say D and C and D ಮಾತ್ರ ಚೇಂಜ್ ಮಾಡಿದ್ದಾರೆ. So we should know that ಇಲ್ಲಿ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಬರೋದ್ರಿಂದ ಇದರದ್ದು ಕೆಮಿಕಲ್ ಶಿಫ್ಟ್ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇರಬೇಕು ಅಂತ ಗೊತ್ತಿದ್ರೆ, so it should be D which is 143, that you can find D 143 here, and C ultimately it should be 125. Therefore correct answer for this is option D and not option C, right? So if you know this resonance concept, definitely without going anything wrong with this question, definitely you can conclude that option D is the correct answer for this. Next question. This is based on Woodward-Fisher rules. Little memory based ಆಗ್ತದೆ, you should remember the rules, otherwise it's not possible or it's not that easy to remember the structures and their corresponding lambda max values. Calculate ಮಾಡೋದು ಹೇಗೆ based on Woodward-Fisher rules, that you should know, right? So two molecules they have given, not even one, they have given two molecules, and let me call this molecule as, let's say, A and this molecule as B. So now I have shown the calculation. So this particular system, A molecule, if you consider that, we can call it as a transoid system. So like conjugated double bonds, if you just consider, so this part and nodidri ant helandre, just to concentrate on this part. This our S trans configuration is, so therefore this is transoid system. And if this is the conjugated part, like no double bonds extending conjugation, so illi ಒಂದು ಡಬಲ್ ಬಾಂಡ್ ಇತ್ತು ಅಂದ್ರೆ ಅಥವಾ ಇಲ್ಲಿ ಒಂದು ಡಬಲ್ ಬಾಂಡ್ ಇತ್ತು ಅಂದ್ರೆ ಡಬಲ್ ಬಾಂಡ್ಸ್ ಎಕ್ಸ್ಟೆಂಡಿಂಗ್ ಕಾಂಜುಗೇಷನ್ ಇದೆ ಅಂತ ಹೇಳಿಕ್ ಬರ್ತಿತ್ತು, ಬಟ್ ಅದಿಲ್ಲ. ಬೇಸ್ ವ್ಯಾಲ್ಯೂ ಫಾರ್ ಟ್ರಾನ್ಸಾಯ್ಡ್ ಸಿಸ್ಟಮ್ ಇಟ್ ವಿಲ್ ಬಿ 214 nanometer. ಡಬಲ್ ಬಾಂಡ್ ಎಕ್ಸ್ಟೆಂಡಿಂಗ್ ಕಾಂಜುಗೇಷನ್ that would have been contributed 30, but ಅದು ಇಲ್ಲ. So next, if you consider the attachments for this conjugated part ನೋಡಿದ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ, here you have one ring residue or alkyl substituents ಎರಡನ್ನು same way ದಲ್ಲಿ ಕೌಂಟ್ ಮಾಡಬಹುದು. So one ring residue here you can find, one more ring residue here you can find, right? So conjugated system ಇಷ್ಟನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ third ring residue, fourth ring residue. So for 4 ring residues or alkyl substituents, it will be 5 per each ring residue, so 5 into 4 ಇದಾಯ್ತು. And then you should even consider exocyclic double bond. This particular double bond, if you consider, it is exocyclic, it is external to this ring, so that will contribute 5 units. And this double bond, if you consider, that will be exocyclic to this particular ring, so therefore this will also be contributing 5. So from exocyclic double bonds, 5 into 2, from ring residues it is 5 into 4, so totally it will be 10 plus 20, 30 addition ಆಗಬೇಕು base value. For base value 214 transoid system, it will become 244, right? So if you consider the system B, everything it is same except the fact that this is cissoid system, this is not transoid system. So this particular one, you can consider that these two double bonds which are in conjugation, they are actually cissoid systems. So cissoid ಮತ್ತೆ transoid, of course ಇದನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ transoid ಅಂತ ಆಗುತ್ತೆ, but cissoid ಮತ್ತೆ transoid ಇದ್ದಾಗ it should be considered that the system it is exactly cissoid, right? So now again here in this case also cissoid system ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ double bond extending conjugation ಇರೋದಿಲ್ಲ. So base value for this, it will be 253. In the similar way, if you count the ring residue and exocyclic double bond, same ಇಲ್ಲಿ ಏನು ಬಂದಿದೆ ಅದೇ ಇಲ್ಲಿಯೂ ಬರುತ್ತೆ. So 253, 30 units it should be added. In this case it will be 283, and the corresponding option 244 and 283, option C you can find, that is the correct answer for this, right? So little memory based, ಯಾಕಂದ್ರೆ Woodward Fisher rules ಗೊತ್ತಿರಬೇಕು ಫಸ್ಟ್ ಥಿಂಗ್, ಅಂಡ್ ಅದನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಹೇಗೆ ಲ್ಯಾಂಬ್ಡಾ ಮ್ಯಾಕ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ಳುವಂಥದ್ದು ಇದು ಗೊತ್ತಿರಬೇಕು. ಅದು ಗೊತ್ತಿದ್ರೆ ಮಾತ್ರ ಆನ್ಸರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರ್ತದೆ. Next question. The next question, it is based on proton NMR, structural elucidation based on proton NMR data. In fact, it is very easy question, and this is actually CSIR net December 11 question. In CSIR net December 11, same question it was asked, same thing it has been taken up. So therefore always ನಾನು ಏನು ಹೇಳ್ತಿರ್ತೇನೆ ಅಂದ್ರೆ, by solving previous CSIR net questions, KSET it becomes easy ಅಂತ ಹೇಳ್ತಿರ್ತೇನೆ. So sometimes or most of the times, at least you can find some 4 to 5 questions repeated or picked from directly previous CSIR net questions. Fine, whatever. So this question, it is easy. If you can just interpret the data in a correct manner, easily we can conclude that 4-methylenizole, that is option C, is the answer for this. So we have two singlets corresponding to 3 hydrogen, one at 2.5, the other one at 3.8. So 3.8 readily it indicates that OCH3 it is, ಯಾಕಂದ್ರೆ oxygen electronegative group ಇರೋದ್ರಿಂದ this gets de-shielded, CH3 protons they get de-shielded, and the value chemical shift it goes to 3.8. 2.5 ಬಂದಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ 2.5 singlet 3 hydrogen ಬಂದಿದೆ ಅಂದ್ರೆ that indicates that methyl group, corresponding methyl group, it is attached to sp2 carbon. ಯಾಕಂದ್ರೆ ಸಿಂಪಲ್ sp3 ಅಟ್ಯಾಚ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಅರೌಂಡ್ 1.5 ಅಷ್ಟು ಒಳಗೆ ಬರ್ತಿರ್ತದೆ. So here also the methyl protons, they are little de-shielded, it is because of their attachment with the sp2 carbon. So if benzene ring is there, you can easily think that this methyl group it is attached to the benzene carbon. Fine. So then this particular pattern, that is doublet 2 hydrogen pattern, that is typical paradise substituted pattern. Therefore easily we can conclude that OCH3 and CH3 they are attached to benzene ring in para manner. So the structure of the molecule it should be this. Fine. So now if you want to eliminate some of the options and then if you want to conclude option C is the answer, that is also possible. Phenol ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಫಸ್ಟ್ ಅಂಡ್ ಸೆಕೆಂಡ್ ಆಪ್ಷನ್ ಅಲ್ಲಿ. ಫಿನಾಲ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ 4 to 7 ರೇಂಜ್ ದಲ್ಲಿ ಬ್ರಾಡ್ singlet is expected due to phenolic OH. That is not there, so therefore you can discard option A and option B. Both of them, they cannot be the correct answers. So in option D they speak something on benzyl alcohol. So benzyl idrunu, like in non-aromatic region, it is expected that corresponding to those two CH2 benzylic group in CH2 proton 6 signal ಇರಬೇಕಾಗಿತ್ತು, ಅದು ಕೂಡ ಇಲ್ಲ. So on that basis even we can discard option D. We are left with option C. Only option C can be the correct answer. Further, if you want to assign the aromatic protons, there are chances that we can go wrong here. O illi attached irodrinda, we can think that so like these protons they get de-shielded and either the chemical shift ಜಾಸ್ತಿ ಬರಬೇಕು ಅಂತ expect ಮಾಡಿದ್ರೆ we go wrong. So here even the other effect, that is the resonance effect of the lone pairs which are present over oxygen, that will slightly increase the electron density over this ortho position, because of which we can expect that these protons, they are little shielded, and compared to this, this will be little shielded. ಅದಕ್ಕೆ ಇದರದ್ದು ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಬರ್ತದೆ 6.2 and this will be 7.2. Of course, this question point of view, even if we don't assign, we can conclude this C as the answer. But for your information, I have given you the fact that exactly this ortho protons that will be giving you 6.8 signal, and this one it will be giving you 7.2 signal. Right. So this is the question. This question I have discussed in the challenge. ಯಾವ question ಮಾಡಬೇಕು ಅಂತ ವಿಡಿಯೋ ಮಾಡಿದ್ರಲ್ಲೂ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೇನೆ. The given key answer, it is wrong, right? So what they are asking is oxidation of isoquinoline with alkaline KMnO4. Isoquinoline with alkaline KMnO4, if you oxidize it, so you will get COH at these two groups or these two positions. And with respect to isoquinoline nitrogen, this will be like 1, 2, 3, 4. So 3, 4 dicarboxylic acid ಆಗಬೇಕಾಗಿತ್ತು. Pyridine 3, 4 dicarboxylic acid ಆಗಬೇಕಾಗಿತ್ತು. But the given answer, unfortunately, it is pyridine 2, 3 dicarboxylic acid, which were the products of oxidation of quinoline with alkaline KMnO4. Avaglu ille bond cleave agutte, and in the case of quinoline, this will be first position, so this will become 2 and 3. 2, 3 answer ಕೊಟ್ಟಿದ್ದಾರೆ. I hope definitely final ಗೆ answer ಬಂದಾಗ ಇದರದ್ದು change ಆಗುತ್ತೆ ಅಂತ ಅನ್ಕೊಳ್ತೇನೆ. So change ಆಗಲೇಬೇಕಿದು, because strongly this can be given reference. Very strong references are available. It is option B, which is the correct answer for this question. Right, this is the next question. This is also simple. Even if you have basic knowledge of organic chemistry, this question it can be answered. Sodium ethoxide, it is strong base, so therefore it will abstract proton either from this methyl group or from this methyl group. Now the question, whether this sodium ethoxide it will abstract protons from this methyl group or from this methyl group, so that depends on the product stability, right? So actually in this case, the sodium ethoxide, it is expected that it should abstract protons from this methyl group, which is second position with respect to the quinoline ring, right? So because whenever it abstracts protons from this particular methyl group, the negative charge whatever we get on this carbon atom, it can be stabilized by resonance, and this N atom, it can be having, or it can take up the minus charge. Same thing, it is not possible if this ethoxide ion it abstracts protons from here. Nitrogen ಮೇಲೆ negative charge ಬರೋದಿಲ್ಲ, so therefore this is more favorable situation. So this is resonance stabilized. Further, we can say that this CH2 group, it will act as nucleophile. Over CH3I, it will attack CH3, and I minus it will be liberated. So one more CH3 group it will be added. So therefore the product of this reaction, it should be ethyl at the second position. That is exactly option A, right? So given answer, it is also a simple question. Next question, this is also very simple, knowledge based. If you know this fact, easily this question it can be answered. Natural silk is, if you know that natural silk, it is actually protein, or it is protein like structure, readily you can answer that proteins, they are nothing but polypeptides, so therefore you can go with option B, right? So in fact, in natural silk, there will be a content called as fibroin, and that fibroin, it is actually a polypeptide. So you can find amide bonds here, right? So you can find amine bonds between amide bonds between in the sense this particular amide bond, it will be called as peptide bond between different amino acids. So straight away we can say that option B is the correct answer for this question. Right, this is also one more straight away question. Isoelectric point, very basic one. So it is the pH at which the amino acid will neither move towards cathode or nor towards anode. That particular pH, we will be calling it as isoelectric point, and exactly it is this hydrogen ion concentration that does not allow migration of amino acid under electric field. So at that particular pH, it is expected that the amino acid, it will be in neutral form, so therefore no net charge over amino acid it will be present. It is because it will be electrically neutral, so therefore neutral species, it will move neither towards cathode nor towards anode, and the correct answer for this is straight away option C for us. It was simple question. Right, so this is little difficult question, and the given answer, it is correct, but So you should know the organic chemistry or say pericyclic reactions, and followed by heating whatever product we get. So that knowledge if we have, then this can be answered. So here it is expected that first between these two reactants, this is phenylsidnone and acetylene, they will undergo 3+2 cycloaddition reaction. So this will be acting as 3 unit, and this will be giving you 2 carbon atoms. So from here there will be bond formation with this carbon atom, this pi bond, it will form sigma bond with this nitrogen atom, and this pi bond, it will shift towards nitrogen, and this plus charge whatever is there on nitrogen, so that will not be there in the product. So this is the product that we get at first step. So in the second step, one carbon dioxide molecule, it will be expelled. So nitrogen lone pair which are restored, so that if you transfer here, and this bond if you transfer here, and this bond if you break here, there will be double bond, and this bond it has been broken, this part it will be removed as CO2, right? So if this part it is removed as CO2, we are left with this part. So this part, if you write it in a proper manner, it will be a 5-membered ring, right? So 5-membered ring, it has been written. So because now this bond electrons, it has shifted towards this, here there will be minus charge, and because this has given its lone pair, there will be plus charge over this. If you again consider the delocalization, so minus charge if I shift here, this pi bond if I shift here, and this double bond if I shift on nitrogen, I'll get this as the product. It will tricky one, but the correct answer is option B for this. Right. This is 63rd question, which is very simple. If you have basic idea of UV spectroscopy of organic molecules, very easily this question it can be answered. Everything they have given. Conjugation increase adaga, they say that lambda max, it shows bathochromic shift. You should know bathochromic shift and lambda max, it will be shifting towards higher wavelength. So bathochromic shift andre lambda max, it increases, right? So lambda max increase ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ, we should know that if wavelength increases, energy of that particular radiation it decreases. Energy decrease ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ homo-LUMO gap ಕಡಿಮೆ ಆಗಬೇಕು. So therefore homo to LUMO gap it decreases. That should be the correct answer for this. And for these three, so like say simple system, 1 double bond conjugated 2 double bonds and conjugated 3 double bonds, if you consider the consider these three systems, homo-LUMO gap, so here it will be more. When there is conjugation, homo-LUMO they come bit close, and when there is further conjugation they come further close, and therefore this energy gap it decreases. And because of this energy gap, decrease in this energy gap, the lambda max where this particular transition happens, homo to LUMO transition, so that lambda max it will increase. So therefore homo-LUMO gap it decreases, which is option A, which is the correct answer for this. Homo-LUMO gap it decreases. Right. So 64th question, this is one more question where little doubt, or definitely there is a doubt with respect to the answer what they have given. We cannot say that whatever answer they have given it is totally wrong, but the question it is incomplete. Question it is incomplete because this is based on this can be either solved based on Cram's model or Felkinine model. Based on both models, this question it can be solved. So maybe I can consider this on the basis of Cram's chelation model or Cram's chelation model. Based on that, I would like to solve this. So, but the thing is that SME group, it's a stereochemistry, it was expected. So SME, now we can imagine it towards the observer or away from the observer. Inu imagine ಮಾಡಬಹುದು. But the given answer, ಅವರು SME group away from the observer ಇದ್ರೆ ಏನು ಆನ್ಸರ್ ಬೇಕು? ಆಪ್ಷನ್ ಬಿ, ಅದರ ಬೇಸ್ ಮೇಲೆ ಆನ್ಸರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. So therefore I consider this SME group away from the observer. In that case, how this question it can be solved? So let's assume that this SME group it is away from the observer. So just for my reference, I'll just see how this ethyl group and hydrogen and SME group they are oriented. Let's say from this side, E bond side ಇಂದ ನೋಡ್ತಾ ಇದ್ದಾಗ ethyl group, from ethyl group first I will next what I get is that, so ಇದು ನಿಮ್ಗೆ rare side ಇರೋದ್ರಿಂದ we should be a bit careful here. So ಇದು rare side ಇರೋದ್ರಿಂದ if we start from ethyl group, next we get SME, then we will come towards this hydrogen, right? So three-dimensionally vichara madidre Et first, SME, and H next. That is the order if you observe the molecule from this particular side. So now I'll write the same model as if I am observing this molecule from this side, so that this O and pH I'll observe little with 180 degree exactly alde idrunu. If from this angle I'm observing the things, I can represent double bond O and pH in this manner. And these three, as I said, right, what I do is one more thing here, because there is chelation possible, zinc compound ಕೊಟ್ಟಿರೋದ್ರಿಂದ it is expected that this O and this SME, it will be forming chelate complex with zinc. So therefore SME, either it has to be here or it has to be here. O, with respect to O, it should be in this position itself. So let me consider it here. Will you consider ಮಾಡಬಹುದು? Let's say I'm considering it here. So now if I just consider the orientation of these three groups, as I said, ethyl group, then SME, then H ಬರಬೇಕು ಅಂದ್ರೆ I should place the ethyl group here. So then in anti-clockwise manner, ethyl group, SME group, and then hydrogen, I'll get it on the rare carbon atom. So now according to the Cramp's rule, hydride, it has to attack from the small side. So small group andre it is H. So therefore hydride, this zinc borohydride, this borohydride will provide hydride. That hydride, it will attack from the small group side. So small group side in the attack ಮಾಡ್ತು ಅಂತ ಹೇಳಿದ್ರೆ this double bond O slightly bend ಹಾಕಿ it goes towards right and OH ಆಗ್ತದೆ. This will be H, and this pH as it is SMEETH ಮೊದಲು ಹೇಗಿದೆ ನಾನು ಹಾಗೆ ಇಟ್ಟಿದ್ದೇನೆ. So now if I convert this say Newman projection to Sawhorse projection, easily it can be done. HOHPH, HOHPH on the rare carbon atom, HSMEET, HSMEET, I have written it like this itself. Next, to convert the molecule to this particular orientation, so they have written pH and ethyl group. This part I have written it as ethyl group on the same plane. For that sake, what I do is, so I'll just keep this rare carbon atom as it is. I just consider the rotation of the front carbon atom, so that this pH group ಇಲ್ಲಿ ಬರೋ ಹಾಗೆ rotate ಮಾಡ್ತೇನೆ. ಇಲ್ಲಿಗೆ ಬರೋ ಹಾಗೆ rotate ಮಾಡಿದ್ರೆ H, it has to come here, OH, it has to come here, right? So therefore I'll get this one. So now if I consider that pH and ET, they are in the same plane as they have represented here, ಈ consider ಮಾಡಿದ್ರೆ, so now I can say that ಇದು pH ಸ್ವಲ್ಪ tilt ಮಾಡಿ ಮೇಲೆ ತಗೊಂಡು ಬರಬೇಕು ಅಂದ್ರೆ H slightly it bends towards the observer, H it is towards the observer, OH it will be away from the observer. On this carbon atom, easily you can find that SME, it should be towards the observer, and H, it should be away from the observer. Exactly this molecule you get. And if you look at the options, OH on rare side, OH on rare side, and SME towards the observer, it is there in option B. Option B is corrected, is the correct answer, provided they had provided the correct stereochemistry of SME group. The other possibility, for which in the same way, for practice sake, SME, if it is present towards the observer, you can just do that, right? So if you do that, what you find is that option C will be the correct answer. So therefore, illi missing irodrinda, SME stereochemistry irodrinda, both B as well as C, they happen to be the correct answer. Eradu barbodu. Illi avaru stereochemistry fix ಮಾಡಿದಿದ್ರೆ ಒಂದೇ ಆನ್ಸರ್ ಅಂತ ಹೇಳಿಕ್ಕೆ ಬರ್ತಿತ್ತು. Because they have not fixed this, right? So if SME, it is towards the observer, then you sequence repeat ಮಾಡಿ ನೋಡಿದ್ರೆ you will get that option C is the answer. But one thing is sure, OH and SME on the same side. Here also it is indicated that OH and SME on the same side. That is not possible. A and D answer ಬರೋದಿಲ್ಲ. B ಕೊಟ್ಟಿದ್ದಾರೆ, along with that even C, they have to consider it as correct answer because they have not mentioned SME, right? So this is one question, and the other question it is based on the quencher, right? So these are the two questions which are doubtful. ಇದರ ಬಗ್ಗೆ ಏನು ಡೌಟ್ ಇಲ್ಲ. Definitely our SME stereochemistry miss ಮಾಡಿರೋದ್ರಿಂದ B and C, both of them, according to me, it should be considered as correct answer for this. Fine. So with this, I am completing all the questions of KSET 21, all the 100 questions. My views on that, it has been given, and even ಯಾವ ಕ್ವಶನ್ಸ್ ಅನ್ನು ಚಾಲೆಂಜ್ ಮಾಡಬಹುದು. ಐ ಹೋಪ್ ಈ ವಿಡಿಯೋ ಪಬ್ಲಿಷ್ ಮಾಡ್ತಿರೋ ಟೈಮಿಗೆ ಚಾಲೆಂಜ್ ಮಾಡ್ಲಿಕ್ಕೆ ಇನ್ನೂ ಟೈಮ್ ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. ಸೊ ಪ್ಲೀಸ್ ಡೂ ಚಾಲೆಂಜ್ ಅಂಡ್ ಟ್ರೈ ಟು ಕ್ಲಿಯರ್ ದ KSET in this attempt itself, especially those who are falling in border, say 130, 140 plus ಇದ್ದೀರಿ, and according to the last cut off, if you feel that ಒಂದು 4-6 ಮಾರ್ಕ್ಸ್ ಜಾಸ್ತಿ ಬಂದ್ರೆ ಕ್ಲಿಯರ್ ಆಗತ್ತೆ ಅಂತ ಯಾರಿಗೆ ಅನ್ಸುತ್ತೆ, ಸೊ ಡೆಫಿನೆಟ್ಲಿ ದೇ ಶುಡ್ ಗೋ ಫಾರ್ ಚಾಲೆಂಜಿಂಗ್, ರೈಟ್? So of course 1000 rupees ಕೊಟ್ಟು ಚಾಲೆಂಜ್ ಮಾಡಬೇಕು, ಬಟ್ whenever you are doing the challenging, please provide proper references. Without references they may not consider, ನಿಮ್ಮ ಅಮೌಂಟ್ ಹೋಗುವಂತ ಚಾನ್ಸಸ್ ಇರ್ತದೆ. ಪ್ಲೀಸ್ ಅದನ್ನ ಮಾಡಬೇಡ್ರಿ. ವಿತ್ ಪ್ರಾಪರ್ ರೆಫರೆನ್ಸ್, ಪ್ರಾಪರ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್, ಪ್ರಾಪರ್ ವೇ, do challenge it at your risk. Fine. If you have not subscribed to this channel, please do subscribe to this channel, and please like this video, and you can share this video to your friends, and press the bell icon if you want to get the updates on new videos in this particular channel. So in future, all the KSET papers I am thinking to upload. So next in a batch wise manner, even I'll be uploading completely KSET 20 paper, all 100 questions inorganic, organic, physical manner ದಲ್ಲಿ 3 separate part ಮಾಡಿ ಅಥವಾ sometimes more than that also I'll be giving you this KSET 20 paper also. So for that, please do subscribe to this channel and plus press bell icon for notifications. Thank you for watching this video. Thank you again.